All right, when you picture military power, what comes to mind? Probably jets, tanks, maybe aircraft carriers, right? But what if I told you the real strength and the biggest weakness of any modern military isn't what you see on the front lines? It's this huge invisible network working just behind the curtain, and that's exactly what we're going to dive into. So what do you think it is? A new stealth bomber? Some kind of unstoppable missile? A massive cyber attack? And yeah, those are all huge threats for sure. But the most fundamental vulnerability, the one thing that can literally grind an entire operation to a halt, it's something way less obvious. Yep, it's the stuff that happens in the background, the incredibly complex web of logistics that moves every single bullet and bandage, and the constant grinding work of maintenance that keeps all that high-tech machinery actually running. For decades, these two things have been the military's true Achilles heel. So let's break that down. We've got these two core weaknesses, logistics and maintenance. And historically, they both shared the same fatal flaw. They were completely reactive. They were designed for a much slower, more predictable world, and they just can't keep up with how fast things move today. This really paints a picture of the old way of doing things, doesn't it? On the logistics side, you were basically just putting out fires. A problem would pop up, and then the system would react, which always meant delays and waste. And maintenance? Oh man, the approach was literally run to failure. You just used a piece of equipment until it broke down, which could lead to catastrophic failures and costly downtime at the worst possible moment. But this is where everything starts to change. The solution to these age-old problems isn't just more people or more trucks. It's a total game changer: artificial intelligence. And the engine behind this whole revolution is machine learning. Here's a simple way to think about it. Instead of a computer just following a long list of pre-programmed rules, these systems actually learn. They sift through mountains of data, spot these incredibly subtle patterns, and learn to predict what's going to happen next. Okay, that sounds cool in theory, but how does it actually work? Let's start with logistics, that whole art and science of getting the right things to the right place at exactly the right time. I mean, the difference here is just night and day. The old approach was all manual guesswork. With AI, forecasting becomes ridiculously accurate because the system is analyzing everything from past supply data to the minute-by-minute pace of a mission. Route planning is no longer a fixed line on a map. It's alive, constantly recalculating for speed and safety based on weather, terrain, even potential threats. The result? You go from a slow, wasteful system to a super efficient, just-in-time supply network. Now, let's flip to the other side of the coin, maintenance. This is where AI basically becomes a fortune teller, helping to keep all that incredibly complex equipment up and running. You know, maintenance has been on a real journey. At first, it was totally reactive. Wait for something to break, then fix it. Then we got a little smarter with preventative maintenance. Fix things on a strict schedule, even if they didn't need it, which was often super wasteful. But now, we're in the era of predictive maintenance. By constantly analyzing data from thousands of sensors, AI can predict a failure long before it actually happens. Let me give you a real-world example. Imagine a fleet of drones. Traditionally, a critical part might just fail out of the blue mid-mission, and poof, you've just lost a multi-million-dollar asset. With AI, the system is always listening to the drone's vibrations, its temperature, everything. It spots a tiny pattern and says, hey, that specific bearing is going to fail in the next 20 flight hours. So maintenance gets scheduled, the part gets replaced during some downtime, and the mission is never at risk. That's the power of seeing the future. And the benefits here are just enormous. Your equipment is ready to go more often. Maintenance costs plummet. Your expensive assets last way longer. You don't need giant warehouses full of spare parts you might need one day. And maybe most importantly, it makes everything dramatically safer for the people on the ground. But here's where it all comes together and gets truly revolutionary. These two huge leaps forward, in logistics and in maintenance, they don't just exist in their own little bubbles. They actually talk to each other, creating a single, unified, intelligent system. It's this amazing feedback loop. The predictive maintenance system doesn't just send an alert to a mechanic telling them to replace a part. No, it also sends a message to the logistics system saying, hey, we're going to need this specific part at this specific location in about 24 hours. And just like that, the supply chain is already in motion, getting that part exactly where it needs to be before anyone's even picked up a wrench. And that really gets to the heart of it all. It's not just about having a smart warehouse over here and a smart engine over there. The real magic happens when those systems are woven together, when they work in synergy to create a force that's smarter, more resilient, and way more efficient.
It's a total shift from having a bunch of separate tools to having one truly interconnected network.
So, this all leads us to a final fascinating question. As these AI systems get better and better at predicting what's going to happen, how does that change the role of the human commander? How do you balance the cold, hard data coming from an algorithm with that gut feeling and intuition that only a person can have? Figuring out that human-machine team, well, that's the next great frontier.